Hello, everyone, and welcome to the course of U.S. History. I am your host, Mr. Samuelson. Today, we are looking at geography basics, really just looking at the most essential things we need to know before we get into deeper topics in geography. Now, our essential question for today, how can geography help us to better understand the world? But before we get into that, let's define geography. Geography here is the study of the physical features of the Earth and its human populations. Now, we can study humans in a lot of different ways, but geographers do it in a very specific way. Geographers study the impact of the Earth on people and of people on the Earth. It's always going to be with that earthbound focus when we're talking about geography. So, what do geographers do? Well, they tend to work for the government. Governments need to study the earth, find out where resources are, what are the dangers potentially to human populations. And we also do it within private industry. This is like for oil and natural gas extraction, you might go survey an area. So geographers do a lot. Hey, yes, you are a geographer. All right, so globes and maps. Globes and maps are two tools used in geography. They're the most common ones, the ones you've probably already been exposed to. Globes are spheres, okay? They most accurately represent our Earth because our Earth is a sphere, right? It is round. Earth right here, okay? The Earth is round, and so this is the best way to look at the Earth. Now, the Earth's accurately shown within a globe. Maps are less accurate, but they're more useful in a lot of important ways. And so we're going to focus mostly on maps because you will mostly be dealing with maps as you study history and geography. So talking about maps, well, there are different ways that you can create maps. But in all cases, what we're looking at is a 2D representation of a 3D Earth. The Earth is a sphere, okay? And there's an essential problem here. How do we make a sphere onto a flat piece of paper? You can't do it without some serious flaws. And all map projections are flawed. They all misrepresent size and the shape of land masses in some way. Take, for example, this map right here, okay? According to this map, which is a Mercator projection, a very common representation of the Earth, we see Greenland as this huge, massive land up on the northern side of the map. And Mexico, this little orange country down here. But the reality of these two nations is that they are basically the same size. Okay? Greenland and Mexico are very close in square mileage. But if you just look at these maps, you think that Greenland is significantly bigger. It's not. Greenland and Mexico are about the same size. This is how maps distort size and shape of land masses. Now, different projections show this in different ways. Again, this is the Mercator projection, with Greenland looking huge, Antarctica looking even larger. Antarctica and Australia are about the same size, right? So anything that's far from the poles is going to get bigger and bigger and bigger in appearance, but not in reality. The interrupted projection, the Goods interrupted projection, tries to account for that, tries to make Antarctica look a little bit smaller and Greenland a little bit smaller. And they do that by cutting out huge sections of the ocean, which really do make like North America and Europe appear to be much further apart than they actually are when we look at the map in this way. The most common one, the one you've probably encountered the most, is a hybrid of these, the Robinson projection. Greenland is not actually this big, but it's closer to its actual size than in the Mercator projection. The distances across the ocean are not perfectly accurate, but they're much closer. So these are the different ways that we look at those projections. All right, so determining location in a map. Most maps and globes too, include these lines of latitude and longitude. Lines of latitude are going to tell you how far north or south something is of the equator. So we have this center line, the equator, and as you go north and south of it, there are these other lines that will tell you how far north and how far south you are. Likewise, there's longitudinal lines that tell you how far something is from the prime meridian. The prime meridian is much more difficult to find. The latitude one is easy. It's the equator. It's right in the middle of the Earth. But with longitude, we've got many different meridians. So we had to pick one of them to be the prime meridian, the central one, the one that was going to be our east-west focal point. Well, it was the British that came up with this system. So it runs through England. That line right there runs right through Greenwich, England, where they came up with this system. And everything east of them is the Eastern Hemisphere. Everything west of them winds up being the Western Hemisphere. East and west is determined by the people who came up with this system. So that leads into our final topic for today, the division of the Earth into hemispheres. Hemispheres are simply the dividing of a sphere into halves. We do this with north and south being located north and south of the equator. So the equator draws that line. North of the equator, you're in the northern hemisphere. South of the equator, you're in the southern hemisphere. Likewise, for east-west, the prime meridian is going to be our dividing line, slicing the Earth in half. East of the prime meridian, you're in the eastern hemisphere. West, you're in the western hemisphere. All right. Well, I hope that you were able to learn something from our lesson today. Got a thing or two out of it. Thank you for joining us, and I'll see you next time. Farewell.